Let's take a look at section 7.4, solving logarithmic and equations and inequalities. So what's going to be really helpful for you to solve these is to know your conversion between exponentials and logarithms. And that's because when we're solving for an unknown, we need to use the inverse to get it alone, right? If I have x plus 5, we subtract 5. We use subtraction, the inverse. So when we're solving for logarithms, we need to use its inverse. The inverse of logarithms are exponentials. And the inverse of exponentials is logarithms. So to solve a logarithmic equation, we must convert to exponential form. Okay, now there's something really important to remember, and that is that we cannot take logs of 0 or of a negative. Okay, so if I have some log base b of x, okay, this x right here cannot be negative or 0. And that's because logarithms are inverses of exponentials, and we can never raise a value, a positive value, to get a negative answer, right? If I use a negative exponent, that just gives me a small number. So we don't get these negatives, okay? So you always have to double check what you're taking the log of must be greater than 0. All right, so let's start solving these. First page is just equations. So to solve on number 1, we see we have a logarithm. So to undo that log base 2 to get x alone, we need to convert. So we have two options. We can convert using our conversion from yesterday, which is x equals 2 to the negative thirds, right? Our base is 2 to the power is what the log equals, and then that exponential equals what we take the log of. I can now solve that. We know how to do that. We get rid of the negative exponent by bringing it down to the denominator, so we get 1/8. Now we have to check that though, okay? If I plug 1/8 in for x right here, am I making sure that that is greater than 0? Yes, that works. So x equaling 1/8 is a solid answer. The other way we could go about solving this is, say it's the same thing, but I'm literally going to take the exponential on both sides. So I'm going to say 2 to the log base 2 of x and 2 to the negative third. Remember, we had a property yesterday that when our bases are the same in exponential form, they just cancel. So I'm left with x equals 2 to the negative third, just like we had before. And then you continue solving. So whether you like to use the conversion or undo the base by using this property, they're really the same thing. Let's take a look at number 4. Number 4 is slightly different because that word log shows up on both sides. Sometimes that's a good thing because when the log with the same base shows up on both sides, that simply just means what we're taking the logs of have to be equal. So I can drop the word logs. I don't have to worry about logarithms at all right now. And I just set those equal. This is a quadratic, so we will move the 3x over so that it equals 0. And now I will factor x minus 4 and x plus 1. So I get x equals 4 and x equals -1. However, we must check those domains. So if I plug a 4 in to the first one, 4 squared minus 4 is positive, so that's good. And 3 times 4 is positive, so that's good. 4 works. How about -1? This would be saying -1 squared minus 4. Well, -1 squared is positive, but 1 minus 4 gives me a negative. So that is no good, which means x equals -1 is no good, and my only solution is x equals 4. Okay? You try numbers 2 and 3. Remember, if there's just the word log showing up once, we need to convert to exponential. If log is on both sides, then we can drop the word log. Now let's look at inequalities. We're going to use similar method for solving these as we just did. However, an inequality gives us more solutions, so more possibilities of having an extraneous solution. With that being said, we have to find those domain restrictions right away and not just do a check at the end. So let's start with number 5. Let's find our domain. Recall, as I wrote above, that x cannot be negative or 0, aka what we're taking the log of cannot be negative or 0. So it has to be greater than 0. Now, again, that's not just telling me the value x, it's whatever I'm taking the log of. So if we look at number 1, in this case, what we're taking the log of is simply just x. So x must be greater than 0. There's nothing to solve there. That's my domain. Whatever answers I get, it has to be greater than 0. So now that I found my domain, I'm just going to go about solving this. So we have 2 options. That's a log base 3. We can convert. Now, when you're converting, it's really important we keep the variable on the side it was to begin with. If you change the sides, then your inequality symbol could be wrong. So how do I rewrite this? This would be x is greater than 3 to the 4th. Or our other option, as I had shown before, is if I was to rewrite this, log base 3x is greater than 4, we raise the first side using that base, 3 to the, and then same thing over here, 3 to the. This cancels, I'm left with x is greater than 3 to the 4th. Okay, so either way works. You're essentially doing the exact same thing. You're converting to exponential 4. So now I'm going to solve. Let me erase that so that we have enough room. So when I solve this, this is simply saying x is greater than 81. So now I do my check. Does this answer, x is greater than 81, cover my domain? Yes, everything greater than 81 is greater than 0. So therefore, my solution of x such that x is greater than 81 works. Everything in that solution set is a solution. Okay, let's look at number 8. So notice on number 8, when I'm going to find that domain, we have 2 logarithms. So I have to find the domain for both. So this first one, I'm going to set what I'm taking the log of. Remember, not just x, but what I'm taking the log of greater than 0. So it has nothing to do with the inequality symbol from the problem. It's that what I'm taking the log of must be positive. So we set it greater than 0. If I add 24 to both sides and then divide by 3, I get x is less than 8, greater than 8. Now we'll do the second one. The second one says negative 5x minus 8. Again, that has to also be positive. So I add 8 and divide by negative 5. When I divide by negative 5, we get an inequality symbol switching. Okay, so there are my domains. Right there and then you may be able to analyze something. But let's solve it out so that you can really see. So when I solve, this time around, the word log is on both sides, the same base, so we can drop that. So I'll simply just have 3x minus 24 is greater than or equal to negative 5x minus 8. When I solve that, isolate the variables to one side. So we'll have 8x is greater than, add 24, 16. Divide, and I get x is greater than or equal to 2. So are there solutions in this answer? So are there any numbers greater than or equal to negative 2 that are also greater than or greater than 8? Yeah, there are some, right? But 2 is not one, 3 is not one, 4 is not one. But once I get to 9, 9 would fit both of those scenarios. However, we have to check both domains. Are there any values greater than or equal to 2 that are also less than -8/5? No. So therefore, my solution does not fit both domains, so there is no solution for this problem. Okay? You go try the other two.